Hello everyone and welcome to AWS Summit Online. My name is Udi Hershkovich and I'm the Business Development Manager for Amazon Kendra. And today I want to talk to you about how we can transform enterprise data searches and interactions with Amazon Kendra. On our agenda today, we're going to talk about the current challenges in enterprise search as we hear them from our customers. We're going to talk about how Amazon Kendra reinvents the enterprise search experience and look a little bit under the hood in Kendra to understand how Kendra works. We'll finish with going through a couple of demos that will give us a sense of how Kendra works in the real world. So let's begin. So today, enterprise search is still a challenge. It is because search accuracy is very low, and our customers are telling us that they're challenged with people not finding the information they seek, as well as the complexity of implementing enterprise search in the first place. And when we started diving a little deeper into these problems, what we found is that low accuracy is mainly a result of having mostly unstructured content across the enterprise. From wikis and blogs, web pages, help pages, corporate policies, and project documentation, these are all narratives. And the tools that our customers have in order to search through these narratives are keyword search engines that are really designed for structured content. They extract text from narratives and lose all that rich context. On the complexity side, it's mainly a data silo problem. Information is scattered all over the enterprise, and you never know where the best answer might be for any specific query. It is no surprise then that our customers are telling us that their employee productivity is impaired, their customer experience is impaired as a result of not being able to find the information they need. And even leading researchers and analysts like IDC say that in nearly 50% of cases, people simply do not find the information they need to do their jobs. So let's see how we have reinvented the enterprise search experience with Amazon Kendra using machine learning. Our goal was to create a highly accurate and easy to use enterprise search service that's powered by machine learning. Machine learning is inherently designed to predict outcomes using models, which makes a lot of sense when you think about the search experience. Let's break it down into a few areas. The first one, when we talk about improving search accuracy, we started by enabling the use of natural language queries. When you ask a question about a narrative, like where is the IT support desk, you're asking for a specific concept like location of a particular entity, or how long is maternity leave. You're asking for a time duration that relates to a maternity leave entity. By focusing on natural language queries, we're able to hone in on the accurate information that people are actually looking for, finding the answer, the passage, and the documents that they need in order to conduct their work or utilize enterprise content. It does not mean that we forego keyword queries. They're quite useful, and we don't expect everyone to transform overnight to using natural language queries. But the same machine learning models can be applied on keyword queries to find more relevant information. The next factor, is that we found that there is not a single machine learning model that is actually going to predict the best possible answers every single time. And so Amazon Kendra uses multiple machine learning models under the hood. It uses natural language understanding to understand the question that is being asked of it and understand concepts, and then uses multiple machine learning models to extract or find different types of answers. For example, reading comprehension extracts answers based on concepts from text. So it understands people, locations, organizations, date, time, and so on. So you can ask a question and extract a specific answer from the text, honing in on exactly what the user is interested in. FAQ matching is another model that allows you to utilize curated content from across the enterprise. There are a lot of questions and answers that have been produced by authoritative sources. And there's an opportunity when somebody asks a question to find the best matching questions and answers that come from that authoritative source. And finally, document ranking. It produces a list of links to relevant documents, but unlike keyword search engines, it actually looks at the concepts or the context of the question using natural language understanding and ranks documents in a much more relevant way. In order for Kendra to actually understand the questions that are being asked, all these concepts and terminology from across different types of questions and domains, Kendra is pre-trained on a very broad set of domains. At the moment, it's 14 different domains ranging from IT to financial services through healthcare and life sciences, energy, news and telecommunications, and more. This allows Kendra to actually understand the questions well and hone in on the right information, helping with the accuracy problem. Finally, as far as accuracy is concerned, because we use machine learning models to execute search, we're also able to improve search results over time. The main word in machine learning is learning. And Amazon Kendra is able to retrain those machine learning models using user feedback, either explicit, thumbs up, thumbs down, voting on what's useful and what's not, or implicit, where specific users are looking at content, click-throughs, what they're actually reading. There are other features that Amazon Kendra utilizes to improve search accuracy, such as relevance tuning, that allows you to prioritize data and search results. For example, if most of your content is news articles, you may want to prioritize search results based on information freshness. Latest news is more relevant. Whereas if it's mostly corporate policies, you may want to prioritize search results based on authoritative source or the author. So much for focusing and solving the search accuracy problem. As far as the complexity problem is concerned, Amazon Kendra solved the data silo problem by implementing what we call native connectors. Connectors allow customers to connect Kendra directly to their data sources, regardless of where they are, on-prem, in the cloud, any cloud, and only provide credentials in order to connect to the different data sources, and Kendra will go out, collect the data, splice and dice it, index it, and make it ready for search. Currently, we support 6 connectors, but we intend to expand that to roughly 20 this year. Customers can also build their own custom connectors using the Kendra API. And we do have a number of partners that can help build those custom connectors for you as well. Making it even simpler, Amazon Kendra has a single console where you can define an index, synchronize data sources, tune for relevancy, test and deploy search applications right from a single console, all consolidated for you. One last point about Kendra is that, like any AWS service, security is job zero for us, as we always say at AWS. And with Amazon Kendra, your data is encrypted in motion and in rest. And we do not use your data to improve models for other customers. It's very important to know. All right, so let's talk a little bit more about how Amazon Kendra works in practice. Getting started with Amazon Kendra is as easy as 1, 2, 3, literally. First step, you create an index. An index is the place where all your data sources are mapped out to and making them searchable, making all the documents in them searchable. Next step is adding the data sources. You basically decide which data sources are relevant and you add them and synchronize them with that index. As soon as that's done, Kendra will notify you that the data sources have been synchronized and you can start testing and deploy your application. Right now, we have 2 packages or editions with Amazon Kendra. We have the Kendra Developer Edition, which is a low-cost edition that allows you to experiment and build POCs. It runs on a single AZ, so it's not highly available and not production grade. We do not recommend it for production. And it has certain limitations like 4,000 queries per day and up to 10,000 searchable documents. But it does come with 750 hours of free trial time, so you can start experimenting at no cost. The other package is the Amazon Kendra Enterprise Edition, which is our production grade edition. It is multi-AZ, it's highly available and reliable, and it starts with 500,000 searchable documents in terms of storage units, as well as 40,000 queries per day capacity. and it's scalable, which means that you can extend with additional units of 500,000 documents and additional units of 40,000 queries per day. Before we jump into the demos, I want to talk a little bit about the use cases for Amazon Kendra. So often when I say enterprise search, people think about internal search within the enterprise, and that enterprise search is only for enterprises. I want to clarify that because that is somewhat misleading. A very common use case is, in fact, internal search, helping increase employee productivity, making sure that researchers can research faster, engineers can proceed and work on projects faster, find the information they need, and supporting different operations like legal, finance, HR, sales, finding the information they need and become more productive. But Amazon Kendra is also used to introduce semantic search into external search, helping improve customer experience on websites and self-service channels, and even in customer call centers, where agents can provide faster answers, better answers to customers and improve customer satisfaction, reducing churn. ISVs, or independent software vendors, are using Amazon Kendra as a way of embedding semantic search by meaning, into applications such as content management, customer relationship management, ERP, and e-discovery applications. And a really interesting use case is with chatbot users, where people are augmenting chatbots with Kendra, because chatbots require, in order to communicate with the user, they need to be configured with specific intents. Amazon Kendra has its own natural language understanding, so you can pass on questions to Kendra which will look for an answer enterprise-wide. So a chatbot that does not understand the question or does not have an answer asks Kendra to find an answer, and Kendra returns an answer from across the enterprise to the chatbot that returns the answer to the user. We have integrated Amazon Lex with Amazon Kendra natively, and it's very easy to build a chatbot that goes far and beyond what a traditional chatbot could do. With that, I'd like to jump quickly into a demo of Amazon Kendra, see it in action in a couple of use cases. Okay, so let's look at a couple of use cases and see Amazon Kendra in action. This is a demo that I've prepared in advance of a self-service customer support use case. Here, as I've explained before, the first step to create an index, already done. Second step is to add data sources, and I have added one data source, which is an S3 bucket that contains 3,100 documents, all web pages, help pages from Amazon.com. All we need to do now is jump into the Search Console, and we can start searching for information. So let's say that I'm an Amazon customer and I got a Kindle book and I don't like it, I want to return it. I can start with a keyword search query and let's say return Kindle book. Amazon Kendra returns a suggested answer. Suggested answer finds the most relevant answer from within all these 3,000 plus documents. And in this case, I see in bolded text up here, you can return eligible Kindle books and comics from manage your content and devices. Seems like relevant if I was asking how to return a book. Amazon Kendra found another answer. Books purchased from the Kindle store can be returned within 7 days of purchase. That's also quite relevant. Because I asked a keyword query and not a natural language question, I may have asked how long can I return a book or how to return a book. Amazon Kendra found relevant answers for my keyword query without being too specific. So let's try something a little bit different. Let's say that I bought a hardcover book, a physical book, and I'm wondering if I return it, will Amazon participate in the postage cost? So let's say I type, how much will Amazon refund for postage? When I ask a natural natural language query. I'm honing in on specific concepts. In this case, Amazon Kendra came back with a specific answer, up to $20. It was able to find the answer from within the text, and we can see Amazon will automatically refund up to $20 for return postage. It also provides this passage so that I can verify that this is actually the right answer and highlight a text so that I can see where this answer came from. If I want to read more, I can always go directly into the document. Now consider the alternative of going into a website and searching for that information. If I copy the same question into Amazon.com help, then I will usually come up with a list of links. And as I already know where it is, I still need to go through into different links and read through various documents, in this case about our returns policies. And even when I find the right document, I still need to read through the document to find my answer. And in this case, it's down here. Amazon will automatically refund up to $20 for return postage. This is great, but Amazon Kendra was able to find the answer right away, saving all that precious time. Let's try something else. Let's say I got an offer from Amazon for a rebate, and I want to know how long it would take to process that rebate. How long to process rebate? Again, Kendra was able to find a time frame, because that's what I asked for, that relates to processing a rebate. So I got my answer right away. Again, I can verify that it's the right answer. And one last example. Let's say that I got a package from Amazon, and I opened it up. I was very excited. I was clumsy, and I dropped it off on the floor. So my product is broken. Now I need to figure out who I need to call in order to help me fix it. So normally I would have to look through Contact Us and look for technical support. But in this case, I can simply ask for, say, phone number for home repair service. Okay. All right, and Kendra is able to identify a phone number from within the text that is exactly what I was looking for, that will help me get the third-party repair service provider to work directly with me to repair my product. All right, so here we've seen a use case of self-service customer support, but I don't want you to think that Amazon Kendra is specifically useful for Amazon.com. As I said before, it is trained on a very broad set of domains, so it can understand highly technical content without having to specifically train or customize it for different domains. So let's take another example. I have an application here that Kendra is used behind the scenes to search through research documentation. This is a collaboration between AWS and the Allen Institute called COVID-19 Search. And here there is COVID-19 related research to help researchers and policymakers accelerate access to information. So let's try something here and see how technical we can get. Let's start with something simple, like when was COVID-19, or when did COVID-19 start? Here, Amazon Kendra searches through tens of thousands of research papers. Many of them are being updated daily to come up with an answer. In this case, December 2019. Again, I get relevant snippet of the information, saying why it was December 2019, which research paper it came from, and there are more suggested answers. In some of them, the answers might be a little bit different. In this case, October 6, 2019 through 11 December 2019 with 95% probability. That's great. I found my answer. I was looking for a time. What if I change the question and I ask where instead of when? Here I'm looking for a different concept. I'm looking for a location. And again, Kendra is able to hone in on the research papers and the specific passages that talk about a location of where COVID-19 originated. In this case, Hubei province in China. In other cases, maybe different, China, Wuhan in China. That's great. And I can go into these documents and read a little more. Let's get a little bit more technical. What if I ask a question like, how long can COVID-19 survive on plastic? I'm interested to know how long can the virus survive. In this case, again, I get an answer. Kendra was not trained on specific life sciences content related to COVID-19, but it was still able to find the right answer relating to COVID-19 can survive a maximum of 4 days on plastic. Now, like with many search engines, I'm also able to play around with filtering, faceting, and I can change what I'm focused on, reducing the subset of content that I'm actually searching through. So the same question, if I only look through epidemiology research papers, might change my answer. In this case, up to 72 hours. Same time frame, but it's written very differently. Let's try something even more technical. What is the RR of COVID-19? RR is replication rate. This is highly technical. And again, we're able to find research documents that talk about different replication rates from different research. Each one is going to be different because it tested something else. But this is what I was looking for. So with these two demos, we actually see two very different use cases. Self-service, customer support in retail versus life sciences, specific, honed in on COVID-19 research. Amazon Kendra was able to find the right answers and surface them for us to use. Let's jump back into the presentation. Aside from these specific use cases, I want to share with you how some of our customers are actually using Kendra today. So PricewaterhouseCoopers built RegRanger, which is a PwC service offering for regulatory compliance. Their goal is to help their customers get to the answers they need faster, even when the right answers may be buried within documents over 100 pages long. As an early adopter, PricewaterhouseCoopers is now developing and testing a new version of RegRanger that uses Amazon Kendra under the hood and allows it to ask natural language queries about regulatory issues, improving dramatically the accuracy and the ability to access information by their customers. At 3M, it's all about accelerating material science research. With over 8,000 material scientists and over 1,200 new projects every year, 3M needs to access information from prior relevant research that may be buried in the many patents they hold in vast knowledge base. In order to do that, they want to leverage natural language queries and hone in on the specific data points that their scientists need to decide where to continue research or where to start it. They're starting to use Amazon Kendra, and they expect that their engineers and researchers will innovate faster, will collaborate more effectively, and will accelerate the ongoing stream of unique products for their customers. The last example is with Baker Tilly. Now, Baker Tilly is a leading advisory, tax and assurance firm that's working to provide insights on market conditions, customer preferences, and trends. They're trying to help their customers find relevant information, the vast amount of content that they've collected over time. Now, to do that, they found that by using Kendra, their clients are able to surface relevant information 10 times faster than when compared to SharePoint full text search. For example, Amazon Kendra allows product managers to ask questions in everyday language, such as, what product is made out of titanium? And Amazon Kendra quickly surfaces answers like relevant product manuals, technical bulletins, service alerts, patent registrations. Previously was not possible with keyword search engines. So to get started with Amazon Kendra, I recommend going to our website at aws.com/Kendra and learn more about Kendra before you begin. I hope this has been useful, and I wish you enjoy the rest of the AWS Summit online. Thank you.